Today, I found this spacesuit. I go to the moving room.
Thank you, everybody. Okay, let's come up with a little fun. This is another application of Robocup at home league. In this league you will see many things like moving robots, planning, rafting things, but this is the very first time the project involves a human being seated on the robot. And this is the case of this autonomous wheelchair that is voice-driven. We want to develop an autonomous device for people, elderly, people with some disease. This is a really important, really interesting project that involves also putting things like big computers, big algorithms into a small computers, into a small application for the people. Right now we will see some demonstration. Hi, Robert. Okay, so in this case, this autonomous wheelchair is capable of navigating, recognizing commands, of course. We are adding a robotic arm, because the idea is that people that sit in the wheelchair could eventually just guide with commands. I will do examples if it's possible. Hi, robot.
I arrived to the moving room. I am going to the place.
Where is the Fanta? Going to another location in this moment. So I'm just demonstrating that it's possible to use this huge. Because as you see, it's really huge compared with the other kind of robots. Actually, I started working in 2005 with this kind of, with the differential robots, and then it becomes much more difficult to try to make this thing, this really big thing, travel into a house like this. And I will demonstrate, I will show a minute how it works with really low resources. You can see here in the screen, and then I will project everything there. And I'm using artificial potential fields to move this wheelchair as well. And of course, we are working not only in driving this wheelchair with the voice, but also with the mind. We're performing some tasks using brain headset, and with brain headset, even problems like, for example, Stephen Hawking could be able, just with the mind, to control. The very first time that the robots and the human are mixing, just based on the knowledge that we have acquired in all those years in the National University of Mexico. Right now, I am in the Free University of Berlin. But we want that the people could eventually get some benefit of the robots. And we want to set aside the idea that the robots could beat the humans and human Right now, I'm going to the kitchen. It took me about 10 years to do this, but okay, it's performing really well. After 10 years of doing this, I'm finally able to take my worker to the kitchen. So now I'm going to show you what are the benefits, how it could be possible to do this. And of course, right now I'm handling a big computer, but all that you have seen is possible to do with just two small processors, Intel Atom. And we will remove completely those processors. We will use just one processor and probably one cell phone to do the speech recognition. So imagine that many big things that you're looking here, many computers, many robots, in 10 years, they will be just inside one tiny microprocessor that could be integrated in your phone or in any application. So that's my work. It's really tough, believe me. It's really tough, and every day we are like, you know this Jenga game where you have a pile, a stack, and then you start taking things. No, that's exactly my project. Now, well, this wheelchair uses two laser scanner, but I made a trick. Actually, the back is completely broken. It's not working. So I even just using one laser scanner, and all is inside that small computer. I will show you how does it works. It's really simple. Let's see. Okay, here it is. So, if you think that this wheelchair is just able to recognize some command, that is completely wrong. It has incorporated an expert system named Fleet. It comes from NASA. In this kind of tool, you can have many we define as facts. I mean, rules. Because I'm alone, I'm the one-man army, by the way. Okay. Facts. Okay, I will show you. This is many things are represented, many big things, like this whole scenario is represented through just about 60 polygons, 60 squares. This is quite simple. This map is just 3 kilobytes big and can be in real time using ray tracing. Only I'm used 11 rays out of the 451 scans per every laser. I'm using a real small number of particles, just 20 particles, and then it's possible to localize. And with this expert system that is really tiny, you can see here, this is zones, the plan, the hunger, and we have many rules that involve having commands. For example, it's possible to the wheelchair, in the meanwhile, while it's traveling from one point to another, to ask things, how are you, what's the climate, or go to that place. And so that's my research currently, is studying all the things that you see here that we were working, well, not 10 years ago, but maybe 7 years ago, in these kind of little devices that integrate artificial intelligence and all this knowledge that you could imagine or you could think, oh, what is this useful for? Okay, nice robots, but every one of us, possibly in one future, it's possible to have, instead of wheelchair, 2 pairs of legs. Thank you very much.
How do you want to apply this to improve the life of a disabled person?
Oh, okay. Let's think about one thing. Sorry for repeating. When we talk about wheelchair, we think about people that have some disease. But what about us? When we were, I don't know, 70 years old or 80 years old, the first people who will use this kind of disease will be us, of course. But yes, for the people with some disease, we're trying to solve, to help them to integrate to the, I don't know, to the normal day life. For example, in Berlin, it's a really good city because it has a public transportation system that has some ramps, and there are a lot of electric wheelchairs. And there are many people, for example in the hospital, that are really interested that we could take all this knowledge into something simpler. For example, I told sometime before that we want to do just with a couple of Kinects and one microprocessor, an autonomous driving kit, less than 700 euros. So that would be really cheap. Yeah, so that is our current research. And then, of course, we start to work with the speech recognition, but then somebody came and told us, oh, but what happens if the people cannot speak at all? Oh, okay, so we have something that we can move the eyes. Oh, what happens if the people cannot move the eyes? Okay, so we're trying to move in the next level, and I'm sure that next year we will demonstrate also with a robotic arm, but we are trying to focus in the human-robot interaction, but not as a way of interaction, just as a way of extension, extending the main capabilities, and probably in the future we will wear an exoskeleton. Another question? Okay, so thank you very much. I hope you enjoy it, and thank you for